In this model, we're going to have a little bit of fun just sampling from different distributions and seeing how they look. So what we're going to do is we've got 7 possible distributions: uniform, triangular, normal, exponential, Erlang, gamma, and Weibull. And we could turn on and off the ability to sample from each. So in this example, if I right click on that little square and say Input Editor, I could turn on and off the ability to sample from that distribution. So a 1 means it's sampling, it's on, and any other number will be off. So I wanted to sample from this one, so I'm going to leave it on. If I wanted to change it to off, I just type in 0 or any other number and click somewhere else and it registers, and you see the color changed. I'll go ahead and change it back to on. There. So we could go ahead and sample from that. And what I'm going to do is show you my controls. And we're going to run it for 2,000 seconds. And we're going to sample once every second from any one that's turned on. Now, one thing to keep in mind is you should keep some upper limit on how long you're going to run this, because we're going to generate a huge number of objects and you don't want to overwhelm your computer. But usually as long as you keep some reasonable limit, you'll be okay. So let's go ahead and sample, and I'm going to run the model. And what you just saw there, the first 3 samples were already generated, and the last one came in at a value of 11.17, so that would be this one right here. Because what we have is a histogram, so the first cell of the histogram is 0 to 1, not including 1. The second cell is 1 to 2, not including 2, etc., all the way up until we have all 100 cells. So in this case, it goes into the 12th cell because it's 11.177, so between 11 and 12. So we'll go ahead and it puts it there. And it'll just continue to do that. So let's run it some more. And we can speed it up a little bit. So it's randomly sampling from that distribution. And every distribution, by the way, we've color-coded to be a different color. So this first uniform one is blue. And I'm going to speed it up some more. And it's doing pretty much what you'd expect. It's spread out. Some are getting hit more than others just because of randomness. Eventually, though, they all get hit. Starts to even up a little bit. And so we've just sampled 2,000 times from the uniform distribution, and it looks pretty much what you'd think it would be. It's not perfectly level, but at the same time, it's pretty spread out the way you'd expect it to be. Now, one cool thing about this is that we could sample different kinds of distributions. So for now, I'm going to go ahead, turn off this uniform, and let's go with an exponential. And for an exponential distribution, and to see exactly what it's doing, I'm going to right click on it here, and we're going to sample a mean of 25, minimum 0, and the highest one's 100. So in reality, the exponential distribution goes up to infinity. It could be any number, but we're only going to chart them if they go up to 100. So there might be some generated that are higher, but we're not going to we're going to throw those away and resample. But in reality, you'd expect to see some going above 100 occasionally. So let's go ahead and run this and see how it looks. So there it goes. So pretty much what you think it would look like. It definitely looks like exponential to me. Now, in reality, there could have been 1 or 2 that were above 100. But as long as we're not playing too close to the edge, we should be okay on that. Now, what we could do on this is, let's turn that uniform back on. And I forgot to show you the exact parameters we were using. For that one, we were doing between 0 and 100, which you probably figured out when you saw the graph. Uniformly distributed. So let's go ahead and turn that back on. And let's say we have one other. Let's say we've got the triangular distribution, and let's turn that one on. And by the way, anytime I turn it on, I have to make sure to hit enter or click on a different line so it registers, or if I make any change. And here with the triangular, we got it from 40 to 100 with the mode of 75. So that looks pretty good. I'm going to leave that as it is. And we're going to go ahead and run that. I'll slow it down a little bit so we have some suspense. Now we're going to see all three of them mixed together, so all different colors. The blue was the uniform, the exponential was the purple, and the triangular is the light gray. We can speed it up. Okay, so it's done. So we've got our 6,000 samples total, 2,000 from each. And what we'll see is we've got a bimodal distribution. It's got two peaks here. And this happens a lot in real life. When you've got things coming from different sources. Maybe you got parts that are coming from different suppliers. Maybe you've got patients coming in, but they're different types of patients. And you collected all the data together. And you go and you put it into your distribution fitting software, and you can't tell what's going on. Nothing fits. And the reason normally is because you got different kinds of data that are being mixed together, just like in this example. Now, we've got the advantage that we saw what we did, and also it's color-coded, but in real life, it may not be color-coded. You might have to do some digging around to figure out why that is. But it's really an interesting thing to know, and very helpful, because you will hit this in real life. So I'm going to clear that out. The final thing to note is we could change the number seeds, the random number streams if we want. And let's go ahead and back to our uniform example. I'm going to turn those two off. And in our uniform example, I clicked on the wrong button. Notice that the random seed is 1. I'm going to go ahead and run this. And every time I run this, it will generate the same ones with that same seed. But notice the pattern. For example, like there's a couple here with a little one down and then more up. So it's got a very distinct pattern that you can remember. Now let's change it to a seed that's not being used by anything else. Let's say 101. That's pretty safe. Okay. And I'm going to run it again. So what we've got here now is we got a similar looking pattern, except the details are different. We don't have that same 3 in a row that goes down and up one. And that's because when we change a seed, we're drawing from the same sequence of random numbers every time we use the same seed. But if we change a seed, we're getting a different sequence of random numbers, even though it's repeatable. So just kind of a cool thing to know that if you usually it's a good idea to try more than one seed just to make sure you didn't hit some very unusual circumstance. So the final thing I'd like to mention is that this is a histogram because we're sampling from continuous distributions, and I would need an infinite number of cells to show it as a true continuous distribution. So we made them 1 unit wide and put 100 of them in. And the second thing is, like I mentioned, was that if any sample is greater than 100 or less than 0, that we resample it. We're not going to show those tails. So for distributions like the exponential that goes out positive infinity, we're going to go up to 100, and we're going to cut off the tail at the end of that just so you're aware of it. Just like normal also goes minus to positive infinity, we're going to cut the tails off less than 0 or greater than 100. And I think normally it will be pretty obvious though if a big part got cut off as a result of this. So anyways, go ahead and play with it, have some fun, and I hope you enjoy learning from it and getting your hands-on experience.